Okay. Hi everyone. Thanks for attending to this PyFluent overview. I will be talking about the APIs related to PyFluent specifically. This work together with my colleague Daria Amadori. Just to give a bit of overview specific to PyFluent in the context of PyAnsys. For Fluent, what the user now can access through Python commands here and Python APIs is both meshing and solver applications. So you can trigger PyFluent in this case for both Fluent meshing and Fluent solver. And you can execute actions for pretty much all the actions that you can do manually or scripting with other languages like journaling or Scheme. So for instance, you can read geometries, create geometries, use the guided workflows, use the legacy commands, and in Solver, you can obviously set up the simulation, define the material, define the models, define the calculation, and then do also Fluent post-processing. As it's being built using a native Pythonic API. You can leverage all the Pythonic elements like query objects, create your own objects, classes, etc. Leverage standard Python tools and standard Python libraries, documentation like Sphinx, or you can use any of the libraries that are out there to manipulate your data and communicate with your Fluent session. For instance, PyVista for data post-processing, visualization, NumPy, SciPy, whatever. There is an important message here when it comes to these Python API libraries for Fluent, which is that this is not thought as a replacement for Scheme. Obviously, you can do mostly what you do in Scheme, you can do it also with PyFluent now. But the idea is that any user that doesn't know anything of Scheme can still reach some full level of automation and a mature level so that you can automate your workflows end to end without any restriction of having to know other languages like specific keywords for journaling or specific actions in Scheme. So as first steps, you can see here a very simple example how you can trigger a session, right? You can just create your own Python script or your journal in a Jupyter notebook or whatever you are interested in, and then just execute Fluent, importing the PyFluent library, calling the launch Fluent method. So here you execute Fluent, and then you can have two options. This can trigger Fluent in the local computer in the background, or you can connect to an existing Fluent session. For example, if you are connecting remotely to a Fluent session that is running on a cluster, on an HPC server, or in a different remote machine where you can have access, you can also connect to that session. So there's different ways you can work on PyFluent. Also from the API paradigm, we have two different ways of working. So if you are a Fluent user, you will know that so far when you do automation tasks and you script things, you have to use either Scheme, which is a more, let's say, complex program there, or a programming language, or you have TUI commands or journaling, right? You can execute actions basically following the text user interface. In PyFluent, we have two different ways of operating interchangeably because we can mix lines from both paradigms. One is the TUI based. And TUI based, basically what it mimics is the text user interface set of commands that you will provide to a journal. So for example, if you are defining a boundary condition and a velocity inlet, for example, in journaling, you will navigate through define boundary condition set and then velocity inlet, and you will start providing feedback to all the prompts that appear there and ask you for input, right? In the TUI base with PyFluent, you can still follow this paradigm by passing over those answers that will prompt as arguments to your method or your function that is invoked following the same structure. So we have defined boundary conditions, we will have defined boundary conditions, set velocity inlet, and then we provide the arguments, the prompt questions as arguments. As you can imagine, this is context dependent. This is not robust because these questions actually depend on the problem, model, etc. that we have at hand. And so we provide, this line is not context robust. We need to adapt. And that's why we had the other way, which is the settings API. And this is the recommended, and probably in the future will be the more, it will gain more and will be the more go-to solution, which is a much more Pythonic way of doing things. And basically, this exposes similar architecture than the GUI tree. So, the different components are structured under different groups. So, for example, in setup, we have boundary conditions, and within boundary conditions, we have inlet velocity. And this is the same paradigm we are following with settings API. So we have an object here that is following this tree structure. So we will go to setup, then boundary conditions, then velocity inlet. And then in velocity inlet, we will invoke one of the velocity inlets, which is this one here, and we will act only on the variables that we want to change. So for example, if in this case, we only want to change the velocity magnitude, then we pass over that variable alone. We don't have to stay giving information about the supersonic initial pressure, turbulence modeling, etc. We just specifically make a modification of the parameters that we want to change. And this, as you can imagine, becomes much more robust because we don't have to make these lines aware of the context, like we have energy or not. In TUI, if we have energy, we'll ask us a set of questions related to the energy. In settings API, it doesn't matter. We are just acting on the velocity. That's it. We don't care about any other models that may be enabled. So here is a very simple example of how you can build up a setup end-to-end workflow. So in this case, I'm just reading in these lines of code. It's very simple how we are launching Fluent, and we are providing the information about how we want to launch Fluent. So we want to launch in what version, what precision, what dimension, how many processors, what kind of mode we want to use as solver mode here, and GUI mode. Then we are reading a mesh file that we have already created in meshing, and we enable energy. See how easy it's there to enable energy. So we did that. We define a material property, water liquid, that you will see. Here is copying the water liquid, and then it's set up that material properties for the zone. It's setting up velocity and temperature for the two inlets that we have in the elbow geometry, initializing, running 100 iterations, and calculating. And then, I can stop that, and for the demo, you can see how that looks like, the whole calculation automated. So from reading a mesh to having these results, you only need, for this specific case, of course, but it's as simple as 15 lines of code. And then, of course, all the post-processing can be built subsequently. For meshing, the paradigm is the same. So we are moving from a very complex journaling scheme that is capturing for example, the workflows, is capturing the workflows and encapsulating through Python wrapper calls into a now Pythonic environment where we are initializing the flow in using Python objects. So this is not context dependent. It allows us to build our own classes. It's much more intuitive to use the workflows. So now it's much easier to build a script where we can trigger these actions. There is what I've been talking about now is PyFluent. So PyFluent, we can use it to control a Fluent session from outside, but PyFluent, Python in Fluent also exists in the TUI. So we will call it PyConsole. It replaces the text user interface as you are used to. It's very easy to launch, so we need to enable beta features, and then we just click on Python console here, and then it enables this Python console where we can use standard Python calls, and we have some functionalities like that, autocomplete. We can leverage different Python Python options. And here is an example. I will just skip through it, but basically how in that same elbow case, one can start writing Python instructions to, for example, build a series of planes following a spline curve along the axis of that elbow that you saw before. So I am just, I'm reading a dictionary that contains the points where I want to create the planes and the normals, just providing, just displaying the mesh here, and then creating a for loop that will loop over all these points and create all the planes. And you will see when I execute that script, just executing it, it will start creating automatically all the planes. So you see it's creating all the planes automatically, and this allows us to automatically create planes along the object following that spline. So one can imagine that it's possible to generate any kind of automation and create that for any kind of geometry and post-processing. So all in all, basically what we get is to make automation simpler there. As you can imagine, because of this Pythonic environment, we have all the standard Python support. So we have auto-completion when we are scripting on these objects. We have the standard help and dir calls, and we have a fully documented Python API in the Fluent site. To help you out build your scripts and get started with, you can always use the PyFluent journaling capability. So basically, you can start in your script. If you are not familiar with the APIs and you want to start getting familiar, you can invoke this journaling start, and this will write a PyFluent journal script in Python that will record all your actions. What you will record is all the Fluent or TUI commands that you pass. If you are in meshing, it will record your workflows and all the commands that you are invoking. If you use Fluent Web UI, and I will show you in the next slide, all your Web UI actions, so all your GUI, your manipulations with your mouse, it will be also recorded in a PyFluent format. What it will not record is if you are reading other Python scripts, or if, for example, you are triggering schemes code, that will not get recorded. The PyFluent architecture is the engine for Fluent Web UI. As you can see here, we have plenty of capabilities to now in Fluent use Web UI to connect to a Fluent session or to launch a Fluent session. Whatever activities you do in that, you have multiple options here to set up a simulation, post-processing, etc. Gets recorded in a Python script, and here you have an example, for instance, of user that is connecting to a Web UI. It has a profile like that, and then enabling the recording. When the recording enables, then every action that the user makes here gets recorded into this script. For example, the load, or for example, if one is creating a velocity inlet, then it will automatically define the corresponding PyFluent code that associates to that action. So, for example, if one sets different models, but it's interesting also that it's not corrupted by wrong commands. So if you open a panel, close that panel, and you don't want to do that, you close it, that doesn't get recorded in the session. And finally, just getting ready, a couple of sources of resources. One is the PyFluent repository on GitHub, the public PyFluent repository. You can log in and start your journey there, downloading PyFluent, and the PyFluent documentation there, where you can have access to examples, the API libraries, guides to become a contributor in PyFluent, and so on. That's all on my side.